Welcome to the lecture series on alkyl halides. In the first lecture, we would start with the classification, nomenclature and formation of alkyl halides. So, the lecture plan for this particular lecture is, first of all, we will talk about what are alkyl halides and what is their significance to the humankind. We would then learn about the classification of alkyl halides and how are they named, that is the nomenclature of alkyl halides. Then we would be seeing some of the methods of preparation of alkyl halides in general, and finally we would sum up the lecture. Before we start defining alkyl halides, let's look into their significance in day-to-day life. If we look around, we'll find number of materials, number of chemicals which are used for various purposes. So, the fire extinguisher which has halon as the halocarbon and used for extinguishing fire. We have refrigerators which we are using every day, have coolants which again are alkyl halides. The doctors, while performing surgery, use anesthetics. Again, they make use of alkyl halides. Plastics have become so common to all of us, and plastic slippers and so many other things of general utility are being used by all of us. Then we have non-stick cookwares, and Teflon coating is used, which again is an alkyl halide. We are using fumigants for various purposes. We are using herbicides, pesticides, etc., and the farmers make a good use of alkyl halides in these. Therefore, we can say amongst various uses of alkyl halides, we are using them as solvents, propellants, coolants in fridges, which is due to their stable, non-toxic, non-inflammable and non-corrosive nature. But here is a word of caution, and that is that because of this stability, sometimes we are not able to make full use of these alkyl halides because it is so difficult for them to get disintegrated. As a result, they are polluting the environment also. Nevertheless, we are using them in fire extinguishers where halogens, carbon tetrachloride, etc. are used, and they are very important feedstocks for polyvinyl chloride, the important component of plastics. Teflon, as we saw, is used in the non-stick cookwares, and in medicine and also in hospitals we are using it as anesthetic. And the anesthetic which we are nowadays using is halothane. Earlier, if you would know it, chloroform was used for this purpose. Then we have a number of herbicides, pesticides and fungicides. DDT was one of the very common pesticides which was used earlier, but it is also banned because of the stability of these alkyl halides. So, we can say that there are a number of uses of these alkyl halides, but still one has to look for some alternatives and also make a judicious use of all this. So, we come to defining alkyl halides. What are alkyl halides? Alkyl halides are also called as haloalkanes, or we call them halogenoalkanes also. These are the compounds in which one or more hydrogen atoms in an alkane have been replaced by halogen atoms. So, generally we are representing an alkyl halide by Rx, and you know that this X has 3 lone pairs on it, which can be shown in the form of these dots, and the X in this Rx can be a fluorine, chlorine, bromine or an iodine atom. Besides that, of course, we have a possibility of the halogen atom replacing either one hydrogen atom, two hydrogen atoms, three hydrogen atoms, or all the 4 hydrogen atoms in case of methane. Therefore, what we get is general CH3X, CH2X2, CHX3 and CX4 type of compounds. And as you can see, the halogen atom is covalently bonded to an sp3 hybridized carbon atom in all the cases. The classification of alkyl halides. Alkyl halides are classified on the basis of how and where the halogen atom is positioned on the chain of carbon atoms. And because of this variability, because of the placement of halogen atom differently in the chain of carbon atoms, the chemical properties of the alkyl halides vary. And as you shall see when we will be talking about the chemical reactions, they pose a lot of variation in the chemical properties. So, the classification of alkyl halides goes by 3 types. We have primary, secondary and tertiary groups. What are these? Primary alkyl halides are the ones where the carbon which carries the halogen atom is attached to only one other alkyl group. We can represent the primary alkyl halides by a general formula RCH2X, and as you can see, R is the alkyl group, X is the halogen atom. The alkyl groups are given the general symbol R, and the carbon to which halogen is attached is called as primary carbon atom. The primary group is represented by this 1 degree symbol, and the general formula as we saw RCH2Br. Suppose we have taken bromine as the halogen atom, we have this primary carbon atom which is attached to a single R group. An example of this kind is propyl chloride, where we have a carbon chain of 3 carbon atoms and chlorine is attached to the terminal carbon to the CH2 group here. The secondary alkyl halides are the ones where the halogen is attached to the carbon which is attached to 2 other alkyl groups. So, the general formula R2CHX, it is similar to what we represented for the primary alkyl halides. The alkyl groups may be same or different. Since we have 2 alkyl groups here, therefore, these alkyl groups may vary. These could be a similar kind or could be different. The carbon here of course is called as the secondary carbon. It is represented by writing 2 degree, and the general way of depicting it will be 2 R groups attached to this carbon. So, it is left with just 1 hydrogen here and bromine is attached to this one. We call this as secondary carbon. The 2 examples for this are Br could be attached to the central carbon. Here in this case where there are 4 carbon atoms, here we have 3 carbon atoms. So, this is isopropyl bromide. In both the cases, bromine atom is attached to the secondary carbon atom which is in turn attached to 2 alkyl groups. Similar to secondary, then we have tertiary alkyl halides. In case of tertiary alkyl halides, the halogen is attached to the carbon which is attached to 3 other alkyl groups. So, we generally represent it by R3CX formula, and the alkyl groups similar to secondary alkyl halides could be same or different. The carbon is called as the tertiary carbon to which the halogen atom is attached. It is represented by 3 degree, and here is the general way of representing it, and these are the 2 examples where in the first case we have all the alkyl groups similar, that is we have 3 methyl groups attached to this carbon to which the halogen atom is attached, whereas in the second case we have 2 methyl groups and 1 ethyl group. So, in this case we have 2 types of alkyl groups, and these all the alkyl groups could be different also. So, coming to naming the alkyl halides, Nomenclature is generally done in two ways. One we call as functional class nomenclature, where the alkyl group and the halide are designated as separate words. So what happens in this case is we are suffixing the halide group, and here the INE of the halogen is replaced by IDE. So what do we say is we get a fluoride, a chloride, bromide or an iodide. We call it functional class nomenclature because we are treating the halogen atom as the functional group in the molecule. So the alkyl group is named on the basis of its longest continuous chain beginning at the carbon to which the halogen is attached. We shall look into one example. See, this is a simpler case where the halogen atom fluorine is attached to the alkyl group, that is the methyl group, and we will name it as methyl fluoride. In this case, again we have a long chain of carbon atoms. We have 5 carbon atom chains, so we call it pentyl chloride. But what do we see in this case is there are 2 types of groups to which this bromine atom is attached. To one side of this carbon is an ethyl group, to the other side is a propyl group. Therefore, what do we say? We include this carbon to this propyl group and we would say that this is the butyl group and this is the ethyl group, and we call it as ethyl butyl bromide. This is a cyclohexane structure and here is iodine atom attached. We call it as cyclohexyl iodide. So, in all these examples of functional class nomenclature, we see that the compound is named by putting the halogen atom as a suffix and giving the alkyl group as the first name. So, the other way we name alkyl halides is substitutive nomenclature. Here the halogen is considered as a halogen substituent on an alkane chain, and what are we doing here is we are prefixing the halogen atom. So, the prefixes which are used in the form of fluoro, chloro, bromo or iodo. The carbon chain is numbered in the direction that gives the substituted carbon the lower locant, that is the lowest position. We shall look into a few examples to understand this. We have one fluoropentane. This is a simpler case because fluorine is attached to the terminal carbon. Therefore, naming this is not difficult, and as the substitutive nomenclature goes, we have fluoro prefixed to the main carbon chain, that is the pentane chain. Here we have bromine at the second carbon atom. So, we are saying that this is 2-bromo. The parent carbon chain happens to be the same, that is pentane. Similarly, we have 3-iodopentane because now the halogen atom is placed at the third carbon atom and the parent chain remains the same. Here we have pentane as the parent chain. What happens when the carbon chain bears both a halogen and an alkyl substituent? The two substituents are considered of equal rank and the chain is numbered in such a manner that the substituent which is nearer to the end of the chain gets a lower number. What does this mean? We shall look into this example to understand. So, we have 5-chloro-2-methyl heptane. The chlorine is attached at the 5th position and methyl is at the 2nd position. How do we decide that we have to name this methyl to be at the 2nd position and the chloro to be in the 5th position? For this, we have to start numbering the carbon chain and have to see what is the lowest number of substituents which is coming here. So, in naming 5-chloro-2-methyl heptane, if we consider from this side of the chain, we will get this chloro at 3rd position, 4th, 5th, 6th position will be taken by methyl. But we are seeing that it is named 5-chloro-2-methyl, and you can appreciate that we are getting a lower number for the position of these two substituents. So, it does not matter whether we have methyl or chloro group, but we have to go by the preference of giving it a lower locant. And if we consider, suppose we turn the sides of these two substituents, we have chloro now in place of methyl and methyl in place of chloro. We will name it 2-chloro-5-methyl heptane. So, this makes it clear that how should we name it if there are two substituents where one is methyl and another is chloro group. IUPAC nomenclature is actually the systematic way of naming all the chemical compounds. We are calling alkyl halides as alkyl halides in a very general manner, and this is a very common name, but the systematic and IUPAC nomenclature is based on their name as haloalkanes. The IUPAC nomenclature considers halogen as a substituent on the parent alkane chain, that is the substitutive way of naming. Thus, we have methyl chloride which has to be named as chloromethane, ethyl fluoride which has to be named as fluoroethane, isopropyl iodide which is to be named as 2-iodopropane, and secondary butyl bromide which is to be named as 2-bromobutane when it comes to IUPAC nomenclature. There are certain rules of IUPAC which is to be followed when we are trying to name the alkyl halides. What does the first rule say? Locate the longest chain and name it as the parent. In case a double or a triple bond is present, it should be mentioned there. The carbon atoms should be numbered from the side so that the substituent gets the lowest number. This can be exemplified by these two examples. Here we have a parent chain which has 1, 2, 3, 4, 5, 6, 7 carbon atoms. Obviously, it will be called as a heptane, and there are 3 substituents. So, how should we number the substituents is that they should get the lowest number, and by that norm we get bromo at the 5th position, and then this methyl at 2nd position, and 4th position is taken by another methyl group. Had we started from the other side, that is from bromo side, we would have got bromo at 3rd position, this methyl at 4th position, and this methyl at 6th position, which would not have been accepted by the IUPAC nomenclature. In the other example, we have exchanged the positions of bromo and methyl, what we did in the earlier cases also. So, now we have bromo at 2nd position, we have methyl at 4th position and 5th position. The other rule of IUPAC says, if there are 2 different substituents present, that is, suppose we have an alkyl and a halo group, then the numbering should be done in such a manner that the substituent gets the lowest number again. You would recall in the previous slides, we did not consider any difference between these two groups while naming by the substitutive way. So, here again we will look into the position of these two substituent groups instead of giving a preference to one group over the other. So, this is named as 1-bromo 3-chloro-4-methyl heptane, and not that we will say that this methyl will come at 2nd position, this chloro will come at 3rd position, and then this bromo will come at 5th position, which would have taken a higher number. What happens if there are different halogens present in the molecule? What do we do about the preferences? We cannot make any preferences, but the halogens should be named in an alphabetical order. So, we have bromo and chloro here along with of course methyl as one of the substituents. So, since bromo is will get the priority alphabetically, therefore, we will name it like 1 bromo 3 chloro 4 methyl pentane and not 3 chloro 1 bromo 4 methyl pentane. That will become a wrong nomenclature. If the substituents are so placed that the two of these get the same number, what should be done? Again, the alphabetical order is to be followed. So, we have these two substituents, whether you start from this side or the other side, you would get second position for the substituent which is placed in these two places. What will we consider is now the alphabetical order. So, we will say that 2 bromo, since bromo will take priority. So, we will start naming from this side, by which bromo will be placed at second position and methyl will come at the 5th position. Accordingly, the name will be 2 bromo 5 methyl hexane and not 5 bromo 2 methyl hexane. Alkyl halides are prepared generally by 3 methods which are more common. There are many other methods also by which we can prepare alkyl halides, but we would take into consideration 3 common methods. The first one is we can prepare them from the alkanes. Alkanes can undergo radical reaction with halogens or the halogen acids and form substitution products. So, what do we have to do is basically use little severe conditions, either increase the temperature or carry out the reaction in presence of sunlight so that we can form alkyl halides also. There is another method we use is from alkenes. Now, you are familiar with a number of reactions of alkenes and you know very well that alkenes undergo addition reactions. The additions generally follow Markovnikov's rule, we are aware of that, and we are again using either halogens or we can use hydrogen halides also for the addition reactions. But what happens if you want a substituent in case of alkenes which is not at the double bond but which is at the allylic carbon? We would like to tell you that allylic carbon is the one which is next to the double bond, and in this case we will call it as allylic substitution. And allylic substitution is relatively easier as compared to the substitution of a vinylic carbon. Vinylic hydrogens are difficult to remove because they have a very high energy which is required to break the carbon hydrogen bond. Therefore, we cannot carry out the substitution reaction in alkenes, but we can carry out allylic substitution. This allylic substitution also has to be done under different conditions. It cannot also be done at room temperature, but it has to be carried out either at high temperature or in presence of light, and obviously when we are carrying it out in light, we will follow a radical mechanism. The third method, here we are using alcohols. So, alcohols can be reacted with hydrogen chloride, bromide or iodide, or also with alkyl halides to form alkyl halides. The details of all these reactions and the mechanisms which are related to these reactions will be taken up in the next lecture of this particular series. So, this is the time to sum up. In this lecture, we talked about the significant applications of alkyl halides in day-to-day life, and also alkyl halides can be classified into primary, secondary and tertiary alkyl halides depending upon whether the halogen atom is attached to a primary, a secondary or a tertiary carbon atom. The alkyl halides can be named in two ways. One is the common name by which we call them alkyl halides, where we are actually suffixing the halogen atom and prefixing the alkyl group. So, we say methyl fluoride, ethyl fluoride, etc. But the systematic names follow IUPAC nomenclature, which has certain rules to follow, and we should name them by prefixing the halogen atom. For example, we say fluoromethane, chloromethane, etc. We saw how alkyl halides can be prepared by the most common methods, which included the preparation from alkanes, alkenes and alcohols. The details of these reactions, these preparation methods will be